Today is 10th of April 2025. Today we'll talk about logistic regression for classification. By number of output, we can distinguish between binary and multiple logistic regression. And by boundary, there can be linear and nonlinear. And by types of classifier, we can distinguish between conditional probability distribution and other distribution. So this is important concept. This is bit an important concept in statistics and data mining, which is, if you see the chart, let's say today it is probabilistic distributional model, which is conditional. We are using conditional probability. Here, probability of y equals to condition on x, y equals to 0, 1, 2, 3. They have three classes, and each probability is 0.5, 0.2, and 0.3. And we have three of classes. When max fx on x, we define, we are maximizing fx and maximize x, and we return fx. But in argmax x fx case, we return maybe xx, and when argmax x fx, in this case, this x will be what maximizing function value. We return x in this case. So the binary classification model, because it is binary, we can write down as probability. But in this case, there were three classes. But basically, binary classification model, there will be two classes, and we can define it as, because it's probability model, probability of y equals to 1 bar x plus probability of y equals to 0 bar x will be 1. And one class can be defined by 1 minus other classes probability. So this is logistic regression, logistic function graph. In this case, t equals to basically beta 0 plus beta 1 x1 plus blah 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 beta p xp, which is when we use in linear regression. We will use function fx equals to probability of py bar x bar, and it will be same as 1 plus 1 over 1 plus blah 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 when we use logistic function. Then t becomes input from the range between minus infinity to infinity, and output will be between 0 to 1. Basically, the property will be when probability of one class is bigger than 0.5, then it will be bigger than other classes. So threshold will be probability of 0.5. We can check it later in the book later. So threshold becomes 0.5. Find known parameter in linear regression case, we will linear regression, and in logistic regression case, we will use MLE, which is f from x to xn. We are finding xk when theta is parameter case to maximizing. So in let's find parameter. Each class will have probability, and each of y will follow Bernoulli distribution with probability p. L, which is pxi and 1 minus p 1 minus xi, and each of pi will follow this formula, which is 1 over log plus exponential 2 minus beta 0 minus beta 1 x1, blah, 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 blah. And basically what we should do is maximize L about parameter b to pi. And we can make a logarithm and we can find it. And also, there's concept of rules come out. Let's think about because this is binary classification model. We have two probability class, and one probability class is probability of winning, and one probability is probability of losing. Then ratio between each other will be 1 minus exponential minus t, which is exponential to beta 0 to beta 1, p1. In this case, all function will be log and ratio between each function. It will be same as log p over 1 minus p. In this case, then input will be 0 to 1, and output will be infinite to minus infinite. We call it logic function. My question is link, we call it link function. My question is every link function is inverse of actual transformation what we are doing? And in logistic function case, we use these rules as link function because it is more intuitive if we think of, because it gives constant impact of coefficient, which means in linear regression case, from beta 0 to beta p, we can intuitively get its coefficients, constant impact of coefficient if beta 0's unit is 1 increase, because we know every big case coefficient, we can easily know. But in logistic functions case, it's a bit difficult. But if we use odds, then we can get very intuitive beta 0 to beta 1 x1 plus blah blah blah. And there's odd ratio concept, which is odds when in ratio between odd when input is x1 equals to x plus 1 and x1 equals to x. There's concept of odds ratio. So with MLE, I will get a very simple example, which is, let's say there is one box, and there is 7 blue ball and 3 number of white ball. Then probability of get blue ball and probability of get white ball, the probability will be 1. And we can define probability function as probability function will be f y will be either p or 1 minus p. Then likelihood function will be it will follow the sample, so it will be multiply all the I equals to 10, because we got 10 samples, p xi 1 minus p xi, each of the sample cases. In this case, p will be 3 and 7. Then what we should do is argument maximizing p cubed 1 minus p 7 arg max on p. Then we can solve it easily if we put log, if we log on it, then p hat will be 3/10. My question, not surely understandable, is what is the concept of except as xi, and what is the yi? Oh. Y will be probability. Probability. Y will be probability. X will be numbers. I can't directly connect probability function and a likelihood function. So if I more organize the conceptual thing, so T is determined by the linear combination of explanatory variable. T equals to beta 0 plus beta 1 x1 plus beta p xp, and that things will be some exact probability of for one class 1/1 plus exponential minus c. So I think I got it. This can be represented as same as p to the y 1 minus p 1 minus y. If y will be y is argument. Yeah, y is argument, so y will be number. Y will be number. And this is observed, it will be observed number. Yeah. From probability function to likely function, we will put observed number, and what we will find is likelihood function. In this case, we will find observed value as parameter. I think likelihood function is put observed value as parameter to the probability function. That is the concept of likelihood function. So if we change the example as Gaussian distribution, let's say there is 1/square root 2 pi e to the minus x over minus zeta square over 2. Then when theta equals to 1, we can do sampling. Then there will be some value x. Then based on x, there will be probability. Then another example. F x based on zeta, there will be 1/√2 pi e to the minus x minus sigma squared over 2. And when sigma is 1, then we can when x is 2.61, 3.73, 2.80, 4.29, 3.12, we will get f x. Yeah, let's say theta equals to 2. In this case, we should define theta. Theta is parameter. Then there will be probability. Then what we should do is multiply this probability, and there's theta equals 3 cases. Then there's each of the probability. We will maximize probability. Then we can guess, let's say when theta equals 3, it's bigger. Then we can assume, in this case, it is bigger. But if we want to really notice exactly which theta is the most bigger, then we should differentiate it. Will be equals to 1 to n 1 over root 2 pi e to the xi minus theta square minus over 2. Then we can get a log on it, and it will be let's see, this is proportional to argument inside exponential is minus sigma theta squared minus 2xi theta plus xi squared. Then if we minimize it, because it's exponential graph, if we minimize it, then how can we minimize it? Sigma theta squared will be sigma theta squared will be m theta squared minus 2 sigma I equals to 1 to n x I theta plus sigma xi squared. And then we are finding theta. Wait a minute. Minimize. We are, yeah. Here, the theta will be 2 and theta minus 2 sigma xi. And in this case, theta will be sigma xi over n. Oh, we find that sigma equals to mu, which is normal distributions mean. Wait a minute. In this case, but the setting I'm confusing is how exactly derivative in respect to, and we first get f will be probability, and the x value. How should I understand each of the x value? Each of the x value is just the value that we put the sample So I think I should understand it as simple. And for the link function, there's a profit function that we usually use in the econometric, which is defined by inverse of standard normal CDF, which is if your input will be 0 to 1, input 0 to 1, and output will be for the real number. And the simple answer why we define it like this is we want to connect it with the linear predictor link function, connect to linear predictor, but I didn't get it why linear predictor is as domain. Now we will see the code together. In this case, we made data and data set defined by samples, and there's one features. Feature will be same with number of informative samples and redundant sample. In this case, just input informative sample, one informative sample exists, and there's two classes, which is binary classes. And for each class, there is only one class, and there's a 42 random state. This is logistic function, how we defined just t. Here we just define it as t, and negative log likelihood when we want to calculate it. And for this is computer, we want to avoid zero probability. We will return minus np.sum, which is log prediction plus 1 minus p, which will be corresponding to 1. Let's think of corresponding to what we learned here. So x1 will be np and beta in it. Then we will print the estimate result. Then we can see each of the datas and how we classify it. Model expected as 1 here, but it should be actually 0, but I don't know why, but thing is here. We can also ask why it is here. Why model define it as 1 can be also check question. And in this case, we are checking x value. There will be beta 0 hat plus beta 1 hat multiplied by x. And right now, we are checking each of x. Beta 1. Are we checking beta 1 or print x1? Confusing is, are we checking beta 1 or x in this case? And with another, this data set has 13 input variables. We're checking B1 coefficient. From this, we change it like this. This is how we need to predict it. And with iris dataset, we are seeing its class beta. And what we are predicting is this is predict probability. Like if you see here, like probability of it will be class A and class B and class C. This is predicting, and this is based on this. Find maximum value and just return what is our predicted value. That is what is given here. So today, thank you very much.